The air is thick. The ground trembles beneath something ancient, something enormous, something that has no interest in your presence, but will end it anyway. You cannot see it yet. You only feel it. That low vibration in the earth beneath your feet, that instinct firing in the oldest part of your brain, telling you to run. And then the dust rises. Welcome to the world of the buffalo. Not the cartoon version, not the soft, dossy silhouette stamped on state flags and history books. The real one. The one that moved across this planet in numbers so staggering that early European explorers thought they were losing their minds. The one that altered river courses, shaped entire grassland ecosystems, and rewrote the rules of what it means to be a megafauna on planet Earth. Scientists spent centuries assuming they understood this animal. They were wrong. Spectacularly, embarrassingly wrong. And what we now know about buffalo across every species, every continent, every geological epoch they have touched is nothing short of extraordinary. There is not one buffalo, there are many, and each one is its own vertical universe, its own empire of muscle and instinct and evolutionary genius. Today, we go inside all of them. Imagine you are standing on the African savanna roughly 70,000 years ago. The grass stretches to the horizon like a golden ocean, and the heat is so physical, so dense, it feels like it has weight. You are not the apex predator here, you are not even close, because moving through that shimmering mirage ahead of you is a creature called Pelorivus, the ancient ancestor of the Cape buffalo, carrying horns that stretched more than 2 meters across, wider than a king-size bed, wider than most modern cars, curving outward like the arms of something that stopped believing in mercy a long time ago. This was not just a big animal, this was an evolutionary statement, a declaration written in bone and keratin that said in no uncertain terms, "I am not prey." That is where the buffalo story begins, in excess, in armor, in the decision taken over millions of years of brutal trial and error that the best survival strategy is not to run, it is to become something that nothing in its right mind would chase. Let us start with the Cape buffalo, Syncerus cafer, the African titan, the one that rangers across the continent have quietly designated as the most dangerous large animal on Earth. Not the lion, not the elephant, not the hippo, though the hippo has a strong argument, the Cape buffalo. And if you spend any time understanding why, you will realize that the danger is not an accident, it is architecture. The skull of a mature Cape buffalo bull is one of the most sophisticated defensive structures ever produced by vertebrate evolution. At the top of the head, the horns do not simply grow outward. They begin by curving downward along the sides of the skull, forming a thick, fused shield of bone called the boss, a structure so dense and so interlocked that it has been measured at over 10 centimeters of solid keratin-wrapped bone at its thickest point. Bullets have been stopped by the boss. Lions have had their skulls caved in attempting to bite through it. The boss is not decoration. The boss is a medieval helmet that grew directly out of the skull, and the animal that wears it has had 60 million years of engineering review. Now, think about what lives under that helmet. Cape buffalo bulls reach weights of 900 kilograms. That is 2 grand pianos. That is a small car. And unlike a car, it accelerates from standing to 55 kilometers per hour in a space that will make your stomach drop. For context, the fastest human sprinter in history took nearly 40 meters to reach top speed. A Cape buffalo bull can be at full velocity in fewer than 10. When it hits something, the impact energy released is comparable to a small vehicle collision. Ribs fracture, internal organs shift. People who survive Cape buffalo attacks describe not the pain, which comes later, but the sound, a deep, resonant crack that they feel in their teeth. But here is where the science gets genuinely strange and where scientists had to completely revise their assumptions. For decades, zoologists characterized Cape buffalo as essentially reactive. Dangerous when threatened, yes, but not strategic, not coordinated. Studies from the late 1990s and early 2000s began revealing something that fundamentally changed that picture. Cape buffalo herds, which can number in the thousands, exhibit what researchers now describe as democratic decision-making. Before a herd moves, the adults vote. They stand. They look in the direction they prefer to travel. They look away. The direction where the most animals gaze for the longest cumulative time wins. The herd moves that way. Not because a dominant bull decided, because the collective intelligence of hundreds of animals, each reading the wind, the grass, the distant water signs, reached a consensus. This is not instinct in the simple sense. This is distributed cognition, a superorganism making decisions. And when one member of that superorganism is threatened, the entire network responds. There are documented cases, verified on film, of Cape buffalo herds pursuing lions that have taken a calf, chasing them down, surrounding them, lifting them on their horns, and walking away. Not in panic, methodically, the way a military unit executes a retrieval mission. These animals do not have a culture in the human sense, but they have something functionally indistinguishable from loyalty. And loyalty in the African bush is a survival technology.
Now cross the Atlantic, cross an ocean and a hemisphere, and land in a different world entirely. The North American Great Plains, a sea of grass that once covered an area larger than Western Europe, and that once contained the greatest land animal spectacle in recorded natural history, the American bison. Bison. The animal that most of the world casually calls a buffalo, technically incorrectly, but historically forgivably, because when you see one, you are not thinking about taxonomy, you are thinking about scale. At their peak, before the catastrophic commercial hunting of the 19th century, American bison numbered somewhere between 30 and 60 million individuals. Pause on that number. 60 million animals, each weighing between 450 and 900 kilograms, moving across the Great Plains in herds that early accounts describe as taking days to pass a single point. Cavalry officers in the 1860s reported that bison herds stretched to the horizon in all directions simultaneously, that the ground shook for hours before a herd arrived and for hours after it passed, that the noise was comparable to sustained thunder, that rivers were temporarily dammed by the sheer density of animals crossing. The American bison did not live in the Great Plains ecosystem. The American bison was the Great Plains ecosystem. Their grazing patterns determined where grass grew short and where it grew tall, which determined where fire moved and where it stopped, which determined where trees could establish and where they could not. Their wallowing, the behavior where bison roll in dirt to control parasites and regulate temperature, created hundreds of thousands of shallow depressions across the plains that filled with water and became the breeding habitats for amphibians, insects, and waterfowl. Ecologists now estimate that the pre-colonial bison herd was responsible for maintaining the grassland ecosystem at a scale that no other single species, including humans, has replicated. And then we nearly erased it in roughly 60 years. By 1889, an estimated 541 bison remained in the wild, from 60 million to 541. That is not a population decline. That is an extinction event interrupted at the last possible moment. The mechanism was industrial slaughter, driven by commercial demand for hides and by a deliberate U.S. government policy of removing the ecological and cultural foundation of Plains indigenous peoples by destroying the animal they depended on entirely. The physics of this destruction were staggering. Hunters equipped with single-shot Sharps rifles could kill dozens of animals from a single stand position without moving, because bison, unlike deer or antelope, do not immediately flee the sound of a gunshot. They look toward it. They approach fallen herd members. They exhibit, in the face of a technology they had never encountered and had no evolutionary framework to interpret, something that looks tragically like grief. That behavioral reality, the social cohesion that made them such effective grassland managers and such dangerous prey for lions, made them catastrophically vulnerable to rifles. The same loyalty that saved calves from predators walked adults into a killing field. But survival, as always, found a way. And the bison recovery is one of the most astonishing conservation stories in natural history. Today, there are approximately 500,000 bison in North America. Most are in managed herds, but wild populations in Yellowstone National Park represent the only continuously wild bison herd in the United States, descended without interruption from the original plains population. And what scientists have discovered in studying Yellowstone bison over decades has forced a complete revision of what we thought we knew about bison physiology. American bison are not just large, they are physiologically extreme. In winter, when temperatures in Yellowstone drop to -40 degrees Celsius, bison enter a state of dramatically reduced metabolic activity, not full hibernation, not the kind of metabolic stasis that drops core temperature, but a suppression of their metabolic rate that allows them to survive on minimal food intake while their massive bodies serve as insulated heat reservoirs. Their fur is so dense and so structurally complex, with a woolly underfur beneath coarse outer guard hairs, that snow accumulates on their backs without melting. They are so thermally efficient that their body heat does not penetrate to the surface. A bison standing in a snowfield is essentially wearing a self-generated cold chamber on its back. The snow stays frozen, the animal underneath stays warm. This is engineering that any Arctic architect would envy. Their skulls are shaped like plows. The massive sloped forehead is not purely defensive, though it works for that too. In winter, bison use their heads to sweep snow aside, pendulum style, uncovering the frozen grass beneath. They swing hundreds of kilograms of skull through consolidated snowpack with a motion that reads as casual. It costs them energy, but the return, access to calories that every other large herbivore on the plains cannot reach, makes the metabolic math work decisively in their favor. The bison does not wait for spring. The bison excavates winter. Now let us move to a different continent, a different geology, a different chapter in the buffalo story, to Asia, to the water buffalo, Bubalus bubalus, and to a relationship between animal and human civilization so deep, so ancient, and so transformative that historians of agriculture consider it foundational to the rise of human society in Asia in a way that is genuinely difficult to overstate. The wild water buffalo, the Arni, is critically endangered today. Fewer than 4,000 individuals survive in fragments of habitat across India, Nepal, Bhutan, and Southeast Asia. The animal you see pulling plows in rice paddies across South and Southeast Asia is its domestic descendant, shaped over roughly 5,000 years of selective breeding into one of the most physiologically specialized working animals in natural history. But to understand the domestic water buffalo, you first have to understand what the wild one was built for, because the domestic version is simply the wild one with the dial turned differently. The wild water buffalo is a semi-aquatic megafauna that evolved in river floodplains and wetland systems across South Asia. It weighs up to 1,200 kilograms, making it the largest member of the bovine tribe, heavier than Cape buffalo, heavier than American bison, and equipped with horns that can span up to 1.8 meters in some individuals. But its most extraordinary feature is not its size, it is its feet. Water buffalo hooves are wide, splayed, and wrapped in a highly flexible pad of soft tissue that acts like a natural snowshoe in reverse, spreading the animal's enormous weight across the soft mud and wet-logged soil of rice paddies and river margins. This is not an accidental anatomical feature. It is precision engineering refined across millions of years of navigating some of the most treacherous walking surfaces on Earth. An animal weighing 1,200 kilograms should sink immediately into saturated floodplain soil. The water buffalo does not sink, it walks. The hoof architecture distributes pressure so effectively that footprint depth in mud is often less than you might expect from an animal 1/3 its size. And the skin. The water buffalo has a deeply pigmented, almost black skin that absorbs heat with ferocious efficiency in sunlight, but is protected from overheating by the animal's behavioral thermoregulation, wallowing, submerging in water and mud for hours at a time, cooling the core temperature passively, while the mud crust on the skin acts as a natural sunscreen and parasite deterrent simultaneously. The mud is pharmacy and air conditioning and armor all at once. When you understand what it is actually doing, it stops looking like wallowing and starts looking like deliberate, sophisticated self-maintenance. The domestication of the water buffalo changed agriculture across an enormous portion of the earth. Wet rice cultivation, the method responsible for feeding the majority of Asian civilizations for millennia, is extraordinarily physically demanding in ways that early agricultural planners had to solve with available biological technology. Flooded paddy fields cannot be worked by the animals that work dry fields. Horses sink, donkeys sink, oxen struggle. Water buffalo do not sink. They are the only large domesticated animal with the physiological tools to work in the conditions that wet rice cultivation requires. And the civilizations that had access to them across India, China, Vietnam, Indonesia, the Philippines, Thailand, expanded their agricultural capacity in ways that populations without water buffalo simply could not match. The water buffalo is not just an agricultural tool, it is a civilizational enabler, an empire builder wearing hooves.
In Vietnam, the water buffalo holds a cultural position closer to sacred than utilitarian. Called trao in Vietnamese, it is the first animal in the Vietnamese zodiac cycle, representing the hard work and patient power that Vietnamese agricultural identity is built around. In rural communities across Southeast Asia, a family water buffalo is an inheritance, a dowry, a measure of wealth. When the animal dies, it is often mourned. The relationship between these communities and their buffalo is not ownership in any simple economic sense. It is partnership. Partnership built over 100 generations of codependence, and it has the weight and complexity of family. Let us step further back in time now, because the buffalo story does not begin with the species alive today. It begins in the Pleistocene, in a geological moment of stupefying biological richness, when the Earth was locked in cycles of glaciation and the megafauna that walked its grasslands and woodlands were operating at a scale that makes the present fauna look almost modest. Bison priscus, the steppe bison, roamed from Western Europe to North America via the Bering Land Bridge, and it was one of the most successful large herbivores of the last ice age. Standing taller than any modern bison, with a shoulder hump built like a structural buttress and horns spanning nearly a meter, it appears in the cave paintings at Lascaux and Altamira with a frequency and artistic attention that tells you everything about its significance to the humans who shared the landscape with it. These paintings are not decoration, they are records. They are the Paleolithic equivalent of nature documentaries, made by people who had watched these animals their entire lives and understood their movements, their social behaviors, their vulnerabilities, with the intimate expertise of people whose survival literally depended on that knowledge. Bison priscus survived the last glacial maximum. It survived the Younger Dryas cold snap. It survived the gradual warming that ended the Pleistocene. And then, roughly 10,000 years ago, it vanished. The steppe bison population was reduced to isolated remnants in the east and west, which evolved separately into the American bison in the west and the European bison, the wisent, in the east. The wisent, Bison bonensis, is now the largest land animal in Europe and exists today only because of one of the most dramatic conservation interventions of the 20th century. By 1927, the European wisent was extinct in the wild. Every last individual had been killed. The final wild population in the primeval Białowieża forest on the Polish-Belarus border, shot by soldiers during World War I.
12 individuals survived in captivity across European zoos. 12. From those 12 animals, every wisent alive today, currently around 7,000 individuals in rewilded populations across Poland, Belarus, Germany, and the Caucasus, is descended. The genetic bottleneck this represents is extreme, and what scientists studying modern wisent genetics have found is simultaneously troubling and miraculous. The population is recovering. Genetic diversity, while still limited, is slowly increasing as mutations accumulate across generations and as careful breeding management introduces variation where possible. The wisent is not out of danger, but it is alive, and its survival reframes the entire question of what conservation can accomplish when human beings decide to make it a priority. Wisent are forest buffalo, and this distinction matters enormously because it represents a completely different evolutionary strategy than the open plains approach of their American cousins. Where American bison evolved in an ecology of vast space, constant wind, and seasonal extremes that rewarded large herds and collective thermoregulation, wisent evolved in the dappled, complex, obstacle-rich environment of European temperate forest. Their bodies reflect this. They are slightly lighter, slightly longer-legged, built for maneuverability between trees rather than sustained acceleration across open ground. Their social structures are smaller, more fluid. Their browsing habits more diverse, eating bark, leaves, and shrubs in addition to grass, in a dietary flexibility that the open plains bison never needed to develop. The Bielowice forest, where both wild and reintroduced wisent populations live today, is itself a biological miracle, one of the last fragments of the primeval forest that once covered most of Europe before agriculture removed it, a place where trees grow to dimensions that make you recalibrate your understanding of what a tree is allowed to be. Walking through Bielowice with wisent present is the closest experience available in Europe to understanding what the pre-agricultural continent felt like. The animals move through the trees with a quietness disproportionate to their size, appearing and disappearing in the undergrowth like something from a mythology that turns out to be true. There is a final buffalo that demands its place in this story, one that most people have never heard of, one that lived in a world so different from the open savannas and endless plains we have been visiting that it might as well be science fiction. Bubalus depressicornis, the Anoa, is the smallest buffalo on Earth, standing barely 70 centimeters at the shoulder and weighing as little as 150 kilograms, and it lives only on the Indonesian island of Sulawesi in a montane forest ecosystem so ancient and so isolated that the species has been evolving independently for millions of years, cut off from the mainland buffalo lineages by oceanic barriers that have never been bridged.
The Anoa is what happens when you take the blueprint of a buffalo and compress it for an island ecosystem where resources are limited, predators are smaller, and the dense forest rewards agility and concealment over the raw bulk that works on the open savanna. It is a lesson in miniaturization, in how evolution sculpts the same fundamental biological design into radically different forms depending on the selective pressures at play. The Anoa is not a baby buffalo. It is a fully realized evolutionary solution, a buffalo that asked a different question and got a different answer. And the answer is a compact, secretive, forest-adapted animal with a surprisingly aggressive temperament that makes it, relative to its body size, one of the most formidable small bovids on Earth. Unfortunately, the Anoa is also critically endangered. Hunting and deforestation on Sulawesi have reduced its population to an estimated 2,500 to 5,000 individuals. The animal that represents millions of years of island evolution, a genuinely unique biological lineage with no close equivalents anywhere else on Earth, is sliding toward extinction with very little international attention. Conservation resources flowed toward the charismatic megafauna, toward elephants and tigers and rhinos, and the Anoa,
Small, obscure, difficult to photograph in dense forest exists largely below the threshold of public awareness. This is one of the great ongoing injustices of conservation priority setting, and it is worth sitting with that discomfort for a moment. All of these animals, the Cape buffalo with its democratic herd intelligence and its boss of bone, the American bison with its snowplow skull and its metabolic winter strategy, the water buffalo with its mud pharmacies and its empire-building hooves, the steppe bison painted on cave walls by artists who watched it with the attention of people who needed to understand it to survive, the tiny anoa navigating Sulawesi undergrowth with the intensity of a creature 10 times its size. All of them are expressions of the same fundamental evolutionary project, a project that began with a common ancestor tens of millions of years ago, a bovid navigating a changing world, and that has since proliferated into every grassland, every forest, every floodplain, and every island ecosystem that could sustain it. The question that all of them were answering across all of those millions of years and all those different environments was always the same question. How do you survive? Not abstractly, not philosophically. Survival is a physical problem with a biological solution, and every anatomical feature we have examined today, the boss, the splayed hoof, the snow-sweeping skull, the democratic vote, is an answer. An answer written in bone and muscle and behavior, an answer that has been tested against lions and leopards and glaciers and droughts and rifles and deforestation and the full indifferent weight of geological time. Most of those answers worked. That is the part that should stay with you. Not the extinctions, though those matter enormously, not the near misses, though those should keep you up at night. The part that should stay with you is that most of these animals are still here. Diminished, yes. Threatened, yes. Reduced to fractions of their former numbers and ranges, absolutely. But still here. Still moving across the land in the ways their ancestors moved for millions of years. Still making decisions. Still maintaining societies. Still solving the daily physical problems of temperature and food and predation, with bodies that represent some of the most sophisticated biological engineering on Earth. The American bison went from 60 million to 541 and came back. The European wisent went from 12 individuals in zoo enclosures to 7,000 walking through ancient forests. These are not just conservation statistics. These are data points in an argument about the resilience of life that should change how we understand both the fragility and the tenacity of complex biological systems. The biology of the buffalo in all its forms is simultaneously a lesson in how close to the edge ecosystems can be pushed and a demonstration of what becomes possible when the pressure is relieved, even partially. When you next encounter a buffalo, in a national park, in a photograph, in a historical account, or in the cave paintings at Lascaux, where the steppe bison strides across limestone walls with a confidence that 10,000 years of extinction has done nothing to diminish, look at it as what it is: an empire, a vertical universe of adapted biology, a survivor that has been answering the same hard question longer than your species has existed. The ground is trembling again. The dust is rising. Pay attention this time.